Hello everyone, welcome back to Atomic Ascent, the place where chemistry becomes simple, logical, and truly fun to learn. If you are a student preparing for competitive exams like JEE, NEET, and other entrance tests, or you simply want to build a stronger command on chemistry concepts, then you are just landed in the right classroom. So without ado, let's get started. So our today's topic of the class is measurements and significant figures. So we know that we are talking about chemistry, right? So chemistry is largely a very experimental science. So it's experimental science. Okay, that means most of things which are we are studying in the chemistry are from experiments. So we do a lot of experiments. Okay, so these experiments are giving us a lot of various results, and through those results, when we have to find them out, we do quantitative measurements. Quantitative measurements. What is the meaning of that? It means that we get to know about quantities. Okay, quantities like length, volume, density, mass. Okay, these all are etc. There are a lot of things, other things also, pressure, volume, you can take a lot of examples. So all these things have a number in them. Okay, and that number leads to the quantitative measurements. Okay, so that is why we in chemistry do a lot of measurement, because it's an experimental science. Now these experiments gives us results in few numbers, and those numbers are written in different formats. Okay, so in this particular topic we are going to talk about those. So there are few things which we know or study in them. Those are called accuracy and precision. These are two things when we study about the measurements in chemistry, we come across these two terms. First one is accuracy. Accuracy means there is a difference. Okay, there is a difference between experimental value, okay, and there is a difference between experimental value and the real value. So you have to remember the difference between experimental value and real value is accuracy, and it should not be more than 0.01. Okay, either it should be plus or either it should be minus. So plus minus 0.01, it should be the only difference which should be present between a number of experimental values and the real value which is present, which we have calculated. And precision means what is the closeness between these two values. Okay, between the two values, it is the closeness. That should be the closest one. Okay, that is precision. Obviously it is not going to be exactly, but it should be the most close. That is called precise value. So that is accuracy and precision. Let's take one example for each of them. Suppose there is an experiment, and in that experiment we got a compound. Okay, and suppose that compound has around 20.60% chlorine in it. Okay, and this is a real value which it has already. And suppose there are two methods, method A and method B, through which we are getting the calculation of these two methods. We get from these two methods we get the mass of or percentage of chlorine. Suppose from one we get 20.14% and other one is 20.48. Take it that, suppose this much we have got. And when we take out the difference between these two, like 20.60, which is the real value, minus what we have got from the experiments, 20.14, okay, and over here 20.60 minus 20.48. Now from these we have got two values. We have got 0. There should be 656% difference, and over here we can see 0. It's going to be 12% difference. So which one is the accurate method? The accurate method will be the method which actually gives us the correctness of the real value. So almost correct real value we are getting from the method B. So this is an accurate method. This one is not an accurate method. That is accuracy. Let's talk about precision now. Suppose once again you have the same compound we have done earlier for the accuracy example. So it has 20.60 chlorine, okay, but there are once again two methods over here, method A and method B, to calculate the uh, experimental value, right? Now remember, over here what is going to happen, that both these methods are going to give very close values, right? Like in suppose we are talking about method A, we got the value 20.55. Suppose we got it like that of fluorine experimentally, and over here we got 20.45. Suppose we got it over here. So difference between 20.60 minus 20.55, okay, we got it 0.05%. This is the difference. And over here it is 20.60 minus 20.45. It comes out to be 0.15%. So as you can see, we talked about the closeness between two values, right? They are almost close, but which one is the most close value to the original value? We get it from the method A. So over here method A is giving us the precise value. Now remember, the accurate value may have large difference between uh, the experimental value, okay, and real value, okay, but in the precision it is very neck to neck competition, and which is the closest one, that is precise value. And obviously in accuracy the closest is accurate value, but it is not going to be, if we are going to compare accurate and precise values, it is not going to be as much close as it is in the precise value, okay. So not all the times all the precise values are accurate, but most of the times all accurate value can be precise, okay. So you can do it like that. So that is called uh, precision and accuracy. So our next topic in the same topic is exponential numbers or scientific notations. So before doing them, you should know that what are these. So during chemistry experiments, we get either very large values or very small values. So what happens with those values is, suppose you are doing an experiment and you're getting this value. There are a lot of zeros over here, and simple person, they can have mistakes in counting the zeros. So that is a problem. And once again, they can also have very small values like this. Suppose this is the value. Once again, this is a very small value, and it is very difficult to remember all the zeros present in that. To counter effect that particular problem, we have come across exponential numbers as scientific notation. So what is a scientific notation? We have heard about exponents in mathematics, so we are going to use that same. What we are going to do, we are going to convert these large and very small values into some exponent numbers. What are these exponent numbers? As you can see, there are so many zeros and they are multiples of 10. So obviously they are written in the 10 to the power anything. That can be x. Suppose x can be positive, and x can also be negative value. So these are the large number which are represented in such. And these scientific notations has a numeral value also, which is represented as n. Now there is few things you have to remember when writing the numeral number. It should have a non-zero digit before a decimal, okay, to the left hand side. And there can be any numbers, zero numbers or non-zero numbers, there can be anything. Okay, suppose I'm taking an example. Let's take this example only, which we have taken already, like this number 10000. I'm not counting these numbers, I'm writing with my whatever my heart desire is. So let's count these zeros: 2, then 4, 6, 8, then there is 10, 12, and 14 zeros are there. So how we are going to convert it into scientific notation? There is a number, okay? What we are going to do, we are going to put the decimal on the very left, okay? One non-zero digit before it. So 1 is a non-zero digit, and after it we are going to put a decimal, and we can write it down like this. And what we are going to do, we are going to convert these all zeros into exponent powers. So there were 14 zeros, so obviously the decimal is shifted to the from right hand side to the left hand side. So it is positive. It is positive, that means it will become 14. So it is the scientific notation or the exponential number for this particular large number is going to be 1.10 raised to power 14. Now let's take the another example which we have taken. A very small number is present. It's extremely small number is present. Suppose I have written like this. Okay. Now what we are going to do? We are going to shift the decimal to the right hand side, and what we are doing over here, decimal should be written after one non-zero digit. So 2 is one non-zero digit, the decimal is added to it after this, which is 6. And how many numbers we have shifted? 2, 4, 6, 8, 10, 12, and 13. So 10 raised to power 13, and we have shifted it to right hand side, so it is going to be negative. Okay, why? Because this particular thing means 2.6 divided by 1 0 0 0, 13 zeros are there. Okay, so this is how the scientific notations are written. And what is the significance of these scientific notation? The significance of scientific notation is that we are actually writing down these extremely large and extremely small numbers into measurable and easy to remember numbers. So that is the only thing which we are doing with over here. You should remember one thing, that is n into 10 to the power Suppose we have taken that x is positive, okay, when decimal is moved to from right to left, okay. If decimal is moved to right, okay, see over here we have moved to the right, then x power is negative. So you have to remember these few things, okay. So this is very important for you while doing certain calculations. Let's talk about how these numbers in the scientific notation are added, subtracted, and multiplied and divided. Okay, so we have to see that how these arithmetic calculations are done with the scientific notations. So we are talking about arithmetic calculations with scientific notations. Okay, so first one, let's talk about addition and subtraction. Okay, so during addition and subtraction, suppose there are numbers given. Suppose I'm taking any example. Let's take an example of addition first. Suppose there is a number 2.35 into 10 to the power 4. Okay, um, plus, and we are adding numbers over here. 3.56 into 10 to the power 4. Suppose these numbers are same, okay, the exponent values are same. So we can take them common, 10 raised to power 4, okay, they can be taken common. And the number numerals are added, 2.35 plus 3.56. Okay, they are just added simply. Okay, let's add them. 1 becomes 9 point and becomes 5. 5.91 into 10 raised to power 4. So this is how the numbers are added if the exponents are same. Or if we have to subtract them, once again similarly, suppose we have to subtract them. 13.56 into 10 raised to power negative 3. Let's take if it is in the power of negative, minus 5.78 into 10 to the power negative 3. We are talking about when exponents are same. Okay, so 10 to the power negative 3, once again these powers are taken common and numeral part is subtracted as such as we have done earlier. The answer becomes 7.78 into 10 to the power negative 3. But if the exponents are not given, powers are not in the same powers. Suppose we are talking about like this 0.3498 into 10 raised to power negative 3, and suppose we are adding it, and 1.342 into 10 raised to power negative, suppose it is 4. Okay, so what we can do, okay, we can do two things. Either we convert negative 3 into negative 10 raised to power negative 4, or 10 raised to power negative 4 into 10 raised to power negative 3. So what we have to do, we have to make these exponent powers common. Okay, so if we convert this, then it is going to be 3.498 into 10 raised to power negative 4. And if we are going to do the another way, then it is going to be 0.1342 into 10 raised to power negative 3. So this is how it can be done. Okay, let's solve this in the 10 to the power negative 4 value. So this has been converted 3.498 into 10 raised to power negative 4 plus 1.342 into 10 raised to power negative 4. Okay, negative 4, 10 raised to power negative 4 is taken common, and 3.498 plus 1.342. Okay, so if we do that, 0, then it becomes 14, it becomes 8.4 into 10 raised to power negative 4. So this is how these are calculated. And what about the minus 1, the subtraction? Once again, suppose we take the same number, 3 point, what was it, 498. It was not 3.498, it was 0.3498 into 10 to the power negative 4. Okay, suppose we are subtracting it, 1.342 into 10 raised to power negative 4. Let me just correct one more thing. Suppose it is not negative 4, it was negative 3 actually. So let's take that and then once again convert it in 3.498 into 10 raised to power negative 4 minus 1.342 into 10 raised to power negative 4. Then let's take 10 raised to power negative 4 common and we are going to minus it. 3.498 minus 1.342. Okay, it becomes 651.2 into 10 raised to power negative 4. So this is how this subtraction and addition is done if the exponent powers are different. Now let's talk about the multiplication and division. Multiplication and division. Okay. For multiplication and division, let's understand in the very common way and then apply it. So there is a number, suppose any number, suppose there is x into 10 raised to power a. Okay, and we have to multiply it with another number y into 10 raised to power b. So if the multiplication is done, okay, the exponents powers are added. Okay, the numbers are going to be multiplied, suppose x and y multiplied by 10 raised to power a plus b. So exponent powers are going to be added. But if the same thing is done, okay, same question is taken, but you have to remember that we have changed the sign, we have divided it. So it becomes x by y into 10 raised to power a, the number which is in numerator. Okay, its exponent power is, and taken in the positive form, and the exponent power of the denominator is subtracted from it. So this is how these questions are done. Let's take a few examples. Suppose 3 into 10 raised to power negative 4 multiplied by 4 into 10 raised to power 3 we have taken. Okay, so numbers are going to multiply, 3 4s are multiplied and power 10s are added. Okay, they are added. Okay, it becomes 12 into 10 raised to power negative 1. Okay, and then there is another factor which is, let's take another factor which is, take the same number 3 into 10 raised to power negative 4 divided 5. Now we are dividing it 4 into 10 raised to power 3. So what is going to happen? This whole number is going to come and go to the denominator. 3 into 10 raised to power negative 4 and 4 into 10 raised to power 3. So when this number is taken on the numerator side, the exponent power is converted from one sign to another. If the power is positive, then it is converted to negative. If the power is negative, then converted into positive. So 3 by 4 into 10 to power negative 4, okay, plus negative 3. So minus minus plus 3 by 4 into 10 raised to power negative 7. Okay, you can convert, you can divide 3 by 4 also, and I think it becomes 0.75 into 10 raised to power negative 7. Okay, so this is how the scientific notations are. Okay, now once again, these are not scientific notation. As you can see, one non-decimal, non-zero number should be before one decimal. So over here, decimal is over here. How we are going to do? 1.2 into 10 raised to power negative 1 into 10 raised to power 1, and it is going to be 1.2. Okay, over here, how does it become? The decimal is shifted from right to left, left to right. Then obviously negative 1 power is added, 7.5 into 10 raised to power negative 8. So this is the scientific notation. This is how these questions of multiplication and division are done. And that's all for today's session. I hope you have understood the concepts and also gained the confidence that how to solve different competition level questions. We will continue the same in the next video. So this is not completed yet. So for the next video, please subscribe. Okay. Thank you so much for watching. Keep learning, keep practicing, and as always, keep ascending. See you in the next video.